Okay, folks, I'm calling this part C. This is from question, or it's similar to question 4, part C of written homework number 2. Okay? And I remember this problem from previous semesters. It's kind of interesting in the way that it's stated. It says without finding the answer. In other words, without figuring out the answer or the quotient of this actual division problem, determine what's bigger, whatever that is, whatever the answer is, or 1. A lot of students in the past they figured out what it was, and then they did a division problem on a number line like we did last week. Figured it out and then compared it to 1. And so that's not really the goal here, though. We want to see if there's a way that we can judge whether or not this would be bigger than 1 without actually figuring out what it is. So that's a little bit of a challenge. How can we approach that? And again, we're not trying to use any kind of shortcuts or anything. All we have at our disposal is, well, I know definition of division from 107A, so we can rewrite that as missing factor. And I also have my definition of a fraction from this semester, so I can establish wholes, visualize where things live, break them up into some number of pieces, and so forth. Okay, so let me, even though I don't want to know what this answer is, I want to be able to call it something. So 3/4 or 3/4 divided by 4/5, whatever that quantity is, I'm going to call it a question mark, right? So this is usually the way I set up a division problem anyway, so then I can write it as missing factor. Okay. How can I now maybe think about this? So let me rewrite that as missing factor. So I can write 4/5 times question mark equals 3/4. And as long as I never actually solve for question mark, then I haven't found the answer, right? So I don't want to know exactly what that is, but I want to think about this. What justified that? That was my definition of division. So to go from this line to this line, I'm using definition of division. Okay, if you want to say MF or missing factor, that's a phrase that we use to describe what's happening, because these two are factors. If we're multiplying them, that one's missing, so missing factor. Okay. So maybe I can reason that out. So I might want to work with that. Let me also take advantage of my commutative property of multiplication. So the commutative property of any operation, if the operation is commutative, says that we can basically swap the positions of two numbers. So addition is commutative, multiplication is also commutative. So I can write question mark times 4/5 is equal to 3/4. And again, as long as I don't solve for the question mark, I'm respecting the problem. Let me justify that. So over here on the right, I'm going to write commutative property. I'm just going to write com property, com prop of what operation? Let's indicate that. Of multiplication, or of, I'll use the X to represent my multiplication. So I don't want to stop short and just say commutative property. Which one, right? Because different operations have that property. So specify commutative property of multiplication, definition of division. Cool. So everything we've done is justified. That's good. If some smart Alex said, how do you know that this is all the same? Well, because I'm using definitions, right? So that's fine. Let me kind of set up some number lines and show and I'm not sure which of these forms is going to be more useful yet, so that's why I want to just have them there. It's like sort of like my toolbox. And let me start to think about this problem. So I want to find 3/4, and then I think maybe I also want to find 4/5 on a number line. So let me set up a line here. Okay. And put let me do it. Since everything on the board is written in black, let me do it, I don't know, blue. Looks that different, but just so this 1 doesn't get up in our way. Let me do something like this. So 0. And I want to find one of those numbers first, I guess. So let me choose the larger denominator and go out, let's say 1, 2, 3. I changed my mind. Let's use the smaller denominator, just because of the length of my line. I made 1, 2, 3, 4 equal length segments. If I put my hole there, then that hole is 4/4. Cool. So we got that, and let me locate 3/4. 1, 2, 3 of them. Locate 3/4. Okay, cool. Now let me locate 4/5. So I think the more information I get on that board, on that number line, the better off I'll be. So this at some point will become old hat. How do I want to do this? I've got 1, 2, 3, 4 segments. So in the previous video, I kind of asked questions. Can I divide 4 into 4 by 5 evenly? Can I split that up into 5 equal groups? No. If I split them all in half, and I had 4 groups of 2 to make 8 smaller groups, can I do 8 divided by 5? No. Right? So you can kind of go through that. Sometimes you'll get lucky depending on if the numbers have something in common that maybe you don't have to go all the way up. But if I split each one of these segments into 5 smaller segments, that will always work. That's like the failsafe. Just take that other denominator and choose to split these pieces up into that many smaller pieces, and then you'll have 4 groups of 5, which is 20. And then since it's got 5 as a factor, then we can take that number and divide it by 5 and figure out how many little segments form the fifths. Okay? There we go. So I want to split each of these segments into 4 smaller segments. 5 smaller segments. So let me do that. So that means I want 4 lines in there. I'm going to use the red marker. So let's say 1, 2, 3, 4. And as always, I'm aiming for perfection. I'm aiming for equal lengths. If it's not 100% perfect, that's okay. You know, I'm not breaking out a microscope or any kind of like ruler here. But if it looks really, really bad, you know, do something about that. So either erase it or whatever. So 1, 2, 3, 4 marks. Let's do another. So 1, 2, 3, 4. Break this guy up. 1, 2, 3, 4. And break this one up. 1, 2, 3, and 4. Okay, so there we go. The blue, as I'm ticking along, I'm gonna go red, 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 blue, like duck, 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 goose, right? So I'm not gonna skip from red to red. The blue ones are in there too. I can extend those a little bit if I like. And there we go. Okay. So I'll use red since the red segments or the red marks kind of indicate my smaller segments. And I think that denominator should be 20. And I could count, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. I can count. Or I could think about that I had 4 blue segments, 4 original segments. Each one became a group of 5. 4 groups of 5 is 4 times 5, and 4 times 5 is 20. Okay, and if I collect all of them, my whole will be 20 over 20. Cool, so we've got that. So what am I doing? I'm doing all this just so I can locate 4/5. So I located 3/4 earlier. I could have done this opposite. So what I said at the beginning was I was going to break my line up into 5 equal segments and locate 4/5. I could have done that first. Then to locate 3/4, though, I'd have to make smaller segments, make something basically where I can form 4 groups and also 5 groups out of the total. That's the goal here, right? So I want 20 because now I can form 4 groups, which are large segments, 4 groups of 5, or I can form 5 groups of 4, and that will work. So as in the previous problem, I've got these little marks. So 4/5 is one of these little marks, but I want to see fifths. I want to see the whole as 5 equal pieces. I want that to be obvious, so I can't miss it. So I've got 20 pieces. I'm trying to share that into 5 equal groups. So 20 divided by 5 is 4. Okay. And when I say share something like that, I'm using terminology from 107A. I know we had different models of division. So division by sharing if you're spreading things out to different people. Division by grouping if you're forming groups of a certain size. So however you want to think about it, I need to show 5 equal groups. I've got 20 pieces. So 20 divided by 5 is 4. So if I group up 4 little pieces, I can accomplish this. So you can do different colored dots if you want. Let me just sort of count. So I'm going to take this 0 line and bold it up with black. And then I want to count 1, 2, 3, 4 little segments and sort of extend that red mark, come down a little bit, and keep going. So 1, 2, 3, 4 little segments, right? 1, 2, 3, 4 little segments. 1, 2, 3, 4 little segments. And finally, 1, 2, 3, 4. I always count at the end. It should work out, but if, God forbid, something went wrong, God forbid might be harsh, but you know, we want to just make sure. So now, do I see 1, 2, 3, 4, 5 of those black pieces? And I do. All right. Let me get them like that, and I'm just going to move some of those labels to the other side. We called that 4/4 in blue because I had my original blue marks. So I see still 1, 2, I see a lot now. I see 1, 2, 3, 4 blue segments. This was 3/4, we called it earlier. I see the 20 little, I'm calling them red segments, and now I see 1, 2, 3, 4, 5 equal length black segments. So I can call my whole, I've already called it 4/4, I've got 20 over 20, and now I can also call it 5/5. And again, I like to use the different colors. I see the reflection there. You might not be able to see that red, it says 20 over 20. I like the colors because then the colors sort of speak, help label it. This is all in the same color, a little bit harder to maybe see. Okay, so anyway, let me locate 4/5. So each one of these black segments is a fifth. So I've got 1, 2, 3, 4 fifths. Okay, I'm talking my way through this, so we've spent about 10 minutes. You know, I'm not claiming you got to take this long for the problem. Just working the way through it though. But you do kind of want to. One way to show to justify your claim here. So this doesn't really. It just says determine which is bigger. But I'm going to say sort of make your don't just claim it, make your claim back up your claim, right? Justify it, prove it basically with is what I'm going to do here. And remember, I don't want to know the quotient. If at the end you want to figure it out, go for it. But I don't want to know. It's like a mystery. I just want to know which is larger. And remember, 3/4 divided by 4/5 is whatever. Even though I don't know what it is, it's something. It is a number, and so I'm calling that number question mark. And so basically, what I'm trying to compare right now is who's larger, question mark or 1. So question mark or 1, that is the question, right? Which one is bigger? So let's think about this. And we're not saying it's 4/5 bigger than 3/4. So let's think about what we've got. Let me think of that equation right there. Question mark times 4/5 equals 3/4. So some unknown number of jumps or pieces of a jump or fraction of jumps, some unknown quantity of jumps of 4/5 wants to land me at 3/4. If I took one jump, so let's think about what we did in the previous video. We set up a secondary number line. Since I've got a question mark times 1, I'm sorry, since I have a question mark times 4/5, let me, below here, draw that. Okay, so I've got a new secondary line, visual aid stretching from 0 over to 4/5. Okay, how many jumps of 4/5 is that? That's one whole jump of 4/5, right? So on the secondary number line, I can label this one jump, and I'm using the x, the multiplication, to mean a jump. One jump of length 4/5 gets me there. Okay, so one jump of 4/5 gets me there. What portion, if I take, so right there, if I want to visualize it up top, one full jump of length 4/5 gets me to 4/5. A question mark, a questionable size jump that I don't know exactly how long it is, gets me to 3/4. Right? So right here, this green mark is some question mark, some questionable size jump of 4/5 is the same as 3/4. That lands me at 3/4. So the question is, if this black jump all the way here, if that distance is one full jump of 4/5, then is this green jump more than one whole jump? Or is it less than one whole jump? Right? So if I take one whole jump of length 4/5, I land at 4/5. If question mark was bigger than 1, then I'm taking more than a full jump. And so that would be a full jump and a little bit more, so I'd be over to the right. Right? So if question mark was larger than 4/5, the destination would get me over here to somewhere to the right of 4/5. However, the question mark looks shorter than that. Right? So this question mark looks not quite one full jump. So to me, question mark looks like a smaller length jump than the 1 was. Right? And so I would claim question mark is smaller than 1. I don't know what it is. I don't know what it is. I did not figure that out. We're almost there. I've got little pieces. I could break this, figure out how many little segments are in that whole of 4/5. But we don't need to do that. We just want, and we really don't want to do that here. We just want to kind of make this argument. Okay, so so I'm thinking of jumps. One full jump of 4/5 lands me at 4/5. I took a unknown jump but stopped at 3/4, which is not quite the way, so that was less than one full jump. the length of that jump is the question mark, so question mark must be less than 1. Okay? Kind of cool. Not intuitive. Not intuitive. If you look at this, it's not, unless you're doing a shortcut and calculating the answer, it's not really, I would say it's not obvious, so you kind of want to explore it a little bit. That's the idea. So you got something similar for part C. Part D changes it up a little, the style, but kind of the same idea. They give you a division problem versus some other number. So that's how we could approach it. Could we have used this form of the equation? Maybe. So maybe you could have. You'd want to know that. You'd still want to, I guess, look at the 3/4. Maybe think that through. So I don't need to do that right now because this way worked. But yeah, maybe that way could work. So if you come up with something, perhaps. But since we wanted this form, and again, I didn't really know which form I wanted to use, so I kind of got both. I set up my toolbox, got everything, justified everything with my reasoning, and then there we go, is the picture. Does this picture, again, so I mentioned in the previous video, does this say it all? Well, I see where one jump of 4/5 is. I see that 3/4 lives to the left of my 4/5, and I see that I'm telling us question mark times 4/5 is that thing. Looks good to me.